One of the neat things in calculus, as far as integration is concerned, is this trick or this rule called integration by substitution. And the way this works is, if this exponent here in the integrand wasn't there, if that 13 wasn't there, then I would probably distribute this 2x to both of these terms inside, right, giving you what, 2x to the third, and then the next term would be 20x, and then we could find the antiderivative of these, okay? But since that 13 is there, we're not going to work this out. We're not going to multiply x squared plus 10 times itself 13 times. That's ridiculous. And then, right, multiply it all by 2x and keep going. It's too much. So there's this really cool concept called integration by substitution, and I'm going to show you how that works right now. Sometimes when you're doing these homework assignments, my math lab or your textbook will give you hints as to what should be the variable of substitution. I'll show you what that means in a second here. But sometimes you have to figure it out on your own. Doing enough of these types of problems, you'll learn what would be a very good variable for substitution. So I'll tell you what. I'm going to tell you what it is right now. Let's let u, typically books, calculus books, let the letter u be our variable of substitution, but it can be anything you want. It could be a p, it could be a b, it could be anything you want. Maybe not an x in this problem, but let's let u equal the stuff inside this parentheses, which is x squared plus 10. Okay, let's let u equal this stuff right here. So if u is equal to x squared plus 10, then I hope you see that inside here, what I'm putting in a block right here, I'm going to substitute, I'm going to rewrite that as the letter u in just a bit here. Okay, so it's going to be u to the 13th in just a moment. But let's keep going with this. Let u equal x squared plus 10. What is the derivative of u with respect to x? All right, so what is du dx for this right-hand side? Well, I hope you see that that's pretty easy. That's just 2x, right? And the derivative of a constant goes away. It's just 0. So du over dx, the derivative of this thing with respect to x, is just 2x. And that just came from that term right there. Let's do one more thing. Let's get dx onto the other side. Let's get this du right here all by itself that's in the numerator. And to do that easily enough, we're just going to multiply both sides by dx, right? If this was algebra, you would just multiply both sides by dx. These guys are now gone over here, and we have du is equal to 2x dx. Now I'm writing it this way because do you see in our original problem a 2x dx? Well, sure. In fact, I'll put it in a bubble here for you. There's my 2x, and there's my dx. Do you see that right there? Yeah, I see a 2x dx in the original problem. Well, we're gonna substitute that as well with du. All right. So everywhere I see a u, I'm going to put in x squared plus 10, and everywhere I see du, I'm going to put in 2x dx. Okay. So let's rewrite this original integral. Ready? Let's rewrite this as. Right, we're going to write this. This is going to be substituted with a u, right? So we're going to write that as u to the 13, and instead of 2x dx, we're going to put in du. Right? We're going to put in du. And now this is a much easier integral to do. You've seen this plenty of times, and I've shown it in separate videos. You want to find the antiderivative of this. By the way, this is considered an indefinite integral. There's no lower limit here, no upper limit, right? So since those are not given to us, this is what's called an indefinite integral. All right, so we're going to have a constant, a plus c, hanging out at the very end of our problem. Okay, let's go find the antiderivative of u to the 13. Well, we just add 1, which is now 14, is our new exponent. That moves to the bottom, right? So the antiderivative of this, or the integral of this, is u to the 14th all over 14. And again, since this is an indefinite integral, don't forget the plus c hanging out here down at the end, because there could be some constant, okay? And if you want to just check it, take the derivative of this, and it should go back to u to the 13th, and sure enough it does. Okay, but don't stop there. There's one more thing we're going to do. They do not want the answer, all right? We're asking what's the integral of all this with respect to x. We're not asking you to find the integral of this thing with respect to u. We want to know what the original, or what the answer is going to be for the original problem with respect to x, not with respect to u. So there's one more thing we have to do to finish off this problem, and that is, let's put back in place of u, let's put what u is actually equal to. It's actually equal to x squared plus 10. So my final answer is going to be x squared plus 10. Right? This quantity is raised to the 14th power all over 14 plus some constant c. And there is my final answer. Right? This is my final answer here. And now I've got my final answer in terms of x instead of in terms of u. That's called integration by substitution. Now let me just show one more thing to you, and that is this. When you have your answer, check to see if it's correct. Let's check to see if this is right, and if it takes us back to our original problem of 2x times quantity x squared plus 10 raised to the 13th power. Okay, so I'm going to check this answer, and the way I'm going to check that answer is I'm going to take, let me write this up here so you can see it. I'm going to take the derivative of this, and let's see if it goes back to our original problem. Now if you want to take the derivative of this, I hope you see that we need the chain rule. Right? We need the chain rule to do this. So let's start with this. I'm just going to cover this up for a second. What is stuff raised to the 14th power? What's the derivative of stuff raised to the 14th power? You know, as if this was stuff. All right. Oh, stuff raised to the 14th power is 14 stuff raised to the 13th power, right? Don't forget, there's still a 14 in the denominator, so what happens to these two 14s? They cross each other out. But wait, what was that stuff that we had? Oh, that stuff was actually an x squared plus 10. That's what it really was, right? And there's one more thing that chain rule says. Chain rule says, okay, now go to the inside and give me the derivative of the inner stuff. Oh, the derivative of that inner stuff is just 2x. All right, and we get multiplied the outer and the inners derivatives together. So, and by the way, the derivative of this constant, well, that's just a 0, so we can ignore that. So let's see, was this our original problem? Was that our original integrand? And sure enough it was, right? It was 2x, x squared plus 10 raised to the 13th, and that's what we have, 2x, x squared plus 10 raised to the 13th. So it worked. That's our check. You can always take the derivative of your integral and see if it goes back to your original integrand. Hope that helps.